We're talking about network sustainability through disaggregated distributed architecture. I'm going to show you or explain to you what does it mean, what is this distributed disaggregated architecture, and of course, how does sustainability apply to networking, which is not really aligned one-to-one, and there is apparently no real reason why not. So this is obviously part of networking and also aligned with sustainability, so two pillars out of the concepts of OCP. My name is Alan Almog. I'm with DriveNet's, pushing strategy or product strategy into the market and probably also back into the company as well. This concept is not something that DriveNets is pushing as a product, but a concept that DriveNets enables, and we would like to see more players in the industry tagging along and providing their expertise on this, because this is definitely not a one-man show, and obviously the OCP is the best stage to push something like that in. DDC, by definition, distributed disaggregated chassis. It's a contribution that was made by AT&T about 2 years ago into the telco project of the OCP. AT&T tried to kind of extrapolate the basic idea of disaggregation, be it separating hardware from software, in two senses. One is the functionality. So not only functionality that suits networking within the data center, but also outside, so the service provider space. And second is scale, taking it from beyond a standalone device and a separate network operating system. Eventually, you would be tagging these along into one monolith element that runs in your data center. We just heard that in the previous presentation. But to take it into something which is distributed as well. So taking the chassis, in fact, and breaking it into its basic pieces. Chassis consists of line cards, fabric cards, routing engines, control cards sometimes, the enclosure itself, the metal enclosure, a mid plane, if you kind of refer to this name, because it goes by different names with different vendors. And then each and every one of these elements is built as a standalone device, and then all these standalone devices are connected one to the other in a closed topology. This is what consists of DDC. What you see here, these sketches are directly derived or are cut and pasted from the contribution, from the spec that was contributed by AT&T. Clearly, this is not a one-man show. This is not a DriveNets product. This is there's an ecosystem behind this. We heard about ODMs pushing things around, and in this environment, definitely this is the case. So there are several ODMs who are providing these white boxes. These white boxes primarily consist of, or even I would say by definition from AT&T, consist of a Broadcom ASIC, but that could also be a different type of an ASIC that is hosted within these boxes. There is a CPU in each and every one of the boxes, and there is some connectivity, and the connectivity is, you can say, naive. It can be optical, it can be copper, it can be active electrical copper. We have all variants, and all of this is supported. The logic is that you have multiple vendors, and therefore you don't have any vendor lock. Right? When you have one vendor that controls everything, hardware, software, and providing a complete solution, then he has control over the network and not the customer, the CSP. CSP in this case applies for both communication service provider, such as AT&T, or cloud service provider, such as Facebook, for example. So I'm just going to use the term CSP in this session. The logic of separating the data from the control plane, or having boxes that can do a lot of data moving and control, that controls or dictates what the functionality of this infrastructure will be, is the basis of what enables sustainability into networking. So what the logic here is to take a chassis, break it into its sub-pieces, so that the limitations of the metal enclosure, power, cooling, scale, all of these are kind of tossed aside, and as well as the network operating system itself, built in a cloud-native manner, distributed over multiple elements. So much for DDC. Let's see what sustainability means. First off, sustainability has several instances, several examples. There's a company called IT Renew. They have a booth here in the expo hall, and they're showing some nice examples of how they use sustainability. Most of these are applied to compute functions, to a certain extent storage as well. The logic of sustainability says that you have hardware which is expensive. Hardware has kind of a base value. You cannot really reduce it to nothing. So you might as well, you made the investment, might as well fulfill it in terms of utilization to the maximum capacity that you can. This is very common when you're looking into compute clusters. The world of HPC, high-performance computing, is kind of very famous for extrapolating the maximum compute out of the CPU or the GPU, whatever processing unit is being used. Very common for compute, very uncommon for networking. And then building products which are available for being reused. So once built running a specific application, they can be then repurposed to be used in a different application, or be used in a different location, or be used in a different size. Again, when looking into a compute cluster, then breaking this compute cluster and using each server even as a standalone or part of a different cluster or growing one is very common. And as I said, there are some examples of this. Not very common in networking. Now, what makes all of this possible is flexibility. And clearly, hardware is hard. That's definitely not flexible. So it's not coming from the hardware side. It's coming from the software side. When you have a network which is defined by software or dictated, the functionality is dictated by software, this is what enables this level of flexibility, and then the options vary. And this kind of opens the door for multiple directions on this. Some examples from what IT Renew, mainly IT Renew, are doing. This is the architecture of the network cloud. Essentially, there is a layer of hardware, a CPU. Like I said, in every box there is a CPU, an NPU. That's typically the Broadcom ASIC, but as I said, can also be a different type of an ASIC. I marked XPU as another processing unit that can be installed into such devices. There is none such currently in production, but that could be a GPU in the future, or a different processing unit that is kind of imposed on the network and embedded into one of these building blocks. Not all building blocks needs to be symmetrical or exactly identical when building into a cluster. This hardware layer is being abstracted towards, or I would say towards APIs, and these APIs interface with service instances, these SIs. All right? And this is one item which we will visit later on in the presentation. The service instances, one example that I can give, and this is what DriveNets has done, is a router. A router is a network function. Typically, we think of a router as a box, but a router is a network function that runs on an infrastructure. In this case, the infrastructure is distributed over multiple devices, and the infrastructure can do a lot more than just an instance of a router. And so one example could be a router. Another example could be a different type of a router. So a core router versus a peering router, so different routing functionalities over the same device. I would even say this is somewhat trivial, at least the concept is. But other network functions, and when I'm saying network functions, you can delve directly into the world of NFV and think what kind of network functions have been developing over the last almost 15 years. None of them has really kind of pulled its way through, and to a certain extent, because they're not running inside the network. So in a way, these service instances can be one of this. There is a northbound API as well, because even though we have an orchestrator that kind of takes care of all of the cluster, you do, in certain cases, want to interface towards a northbound SDN controller or a management platform which is owned by the CSP themselves. So this kind of API is also enabled from top and from the bottom. A couple of examples, or 3 examples actually, to kind of showcase how does this apply to networking. So first example is very simple, it's scale. A cluster can reach, with today's available equipment, let's say, about 700 terabit per second. When I look at routing, that's more than 2x of the biggest router, other alternative from this option. Now, it's not about scale, because when you look at a standalone router, 700 tera is a lot, probably more than anybody needs today. But when you look at multiple instances over that same infrastructure, then this resources, this pool of resources is being consumed in a different way. That's step A. Let's make an example. This could be a core router which is running today at AT&T, and then 2 years down the line, this core router has exhausted its path, or AT&T has decided to shift onwards to a different speed, and then they have these boxes that they need to remove from the network. What do they do with these boxes? They can repurpose that same box to be implemented in a different place in the network, serving a different purpose. That's the reuse of the functionality. And of course, in terms of scale, you don't need to take that huge, if assuming that would be chassis-based router, then we're looking at something that weighs almost half a ton with a huge capacity and a physical size. You cannot really position this anywhere you want in the network because there's always some limitation. So when it's broken down into these Lego pieces, you can reassemble these Lego pieces elsewhere in multiple clusters even, like it's shown here in the example. So this option is there and available. Second is with the sense of functionality. Like I said, again, I'm going to start from the basic routing function, a core router, basically because that's the example that is currently actively running, and then repurposing, be it for a smaller size of a cluster, or adding an additional functionality, mounting this onto the existing implementation, or taking that implementation and then again disaggregating it or breaking it to its basic pieces, decommissioning the router itself, the complete node, and rebuilding something different. And in this case, that could serve a different function. An edge router, you can add, say, in this example here, a DDoS function as a third-party network functions, which is embedded on top of that, that implementation. And of course, in terms of network positioning, it's not to say that that DDoS function would not mean a lot when being applied onto a core router, but when being applied to an edge router, then that would make more sense in terms of network functionality. And these types of network functions or software-controlled functionality is something that can be embedded onto an existing platform. And you know, again, this level of flexibility is enabled by the fact that this is software-controlled rather than hardware-based. And third example is talking about geography. I kind of hinted to this, that you know, positioning a big device in a core, repositioning these boxes onto a certain or different location, physical location in the network, enables more flexibility because of the size, actual size of the boxes. But one example that I can give from the world of HPC, when high-performance computing clusters are being implemented, typically they are top of the line, targeting to be one of the top, I don't know, 20 supercomputers worldwide. 2 years down the line, you're outside of the top 500 list already with that same cluster that, you know, 2 years ago it was really amazing. 2 years later, it's kind of old and shabby, but it's old and shabby for the application or for these labs who are, you know, on top of the line in terms of their performance or what kind of applications they're using or developing. When you take this sideways towards other territories such as Africa, Latin America, Middle Eastern, then these same clusters are being repurposed. This is fact, not the kind of concept. These same clusters are being kind of taken out from one of the, I'd say, national labs here in America and taken and being installed in Africa and being used for universities for their purposes. And obviously, this kind of extends the lifespan of this equipment for an additional 3, 4, 5 years. So geography also plays a significant role here. All right. Now, I hinted for several of these, but just to kind of highlight what I had in mind, and perhaps I'm starting to kind of go towards a call to action here. Routing functions, core aggregation, peering, PPE, or LER, LSR, depends how you want to call it, that's on the routing layer. And then the traditional, I'd say, network functions, firewall, DDoS, a NAT function, load balancing, DPI, these network functions have made their attempt to a certain extent successful, to a certain extent not very successful in the world of VNFs. Some even try to shift into CNF mode of implementation. These need to be implemented on top of such API that is embedded into the network, which will enable these applications to be spread throughout the network. There are certain kind of beginnings of such implementations. We are working with a few companies, both in order to kind of assist them in developing their existing application. The expertise is not coming from us in terms of how to develop a firewall or a DDoS. That's not what we do. But we're working with expert companies who are doing this with the idea of us helping them to build it towards an existing API that would enable that network function to be spread throughout the network. So the definition of this API is kind of a shared work between ourselves and the third party. We're definitely looking for more of such engagements. The logic here, or the purpose, is to have this API as something which is open and available to the entire public, and not something which is, proprietary either to whoever is providing the platform or whoever is providing the network function. This needs to be open, otherwise it's going to be useless. Subscriber management, this comes from the world of mobile networks or residential networks. Registering a function like a BNG or even a 5G core can be applied into this. Location or latency sensitive services, extrapolating a service, not only kind of embedding it in the cloud, which is kind of behind a lot of mileage and as a result latency. So extrapolating these functions, it makes a lot of sense. You hear it all over the place with edge computing. So where is this edge and how does it look like? It doesn't have to look like a server. It can look like the network itself. And then, of course, latency is going to be the minimum physically possible. So again, extending this towards something of a latency-sensitive service. An example here can be even a gaming application or this gaming service side of the application while the gamers are at home and they enjoy the best SLA or quality of experience, I should say. IoT, which kind of booms into multiple options. I'm not even going to kind of explore what this can mean because you all have your idea and you're probably all right. And then innovation. And innovation perhaps is somewhat matched up with what we've seen in the previous presentation with P4 programmability. I don't want my customer, the CSP, to reinvent the wheel and build a firewall out of scratch. No, there are expert companies who are doing this. But I do want him to have the ability to innovate, to make a twist, to make himself stand out versus his competition. So this level of innovation, self-built type of applications is something that this API should enable service providers to push into the market and differentiate, again, themselves versus whatever competition that they have. All right, I will jump through this. This is just to show kind of an illustration of the fact that network resources are not being fully consumed by a single application. I'll just take this blue deltoid here. Where is it? There it is. That's kind of a reflection of a core function. Core function uses a lot of bandwidth and doesn't use a lot of the other resources. So neither QoS or a CPU or TCAM resources are not being heavily consumed by a core router, but still you build a whole huge device because you need a lot of capacity. All of the other resources are left idle. They're there. They're just not being used. So kind of multiplexing multiple use cases over the same infrastructure does make sense. Okay. Where can this go? Where can this take us? Or where do I expect the industry to take this moving forward? So like I said, the API, it needs to be standard. It needs to be open. Otherwise, it's useless. So we need to work with additional companies. We want to see more companies with this expertise of building these network functions as a cloud-native functions over what will be defined, one step at a time as an API, so that additional players can kind of tag along and add their input into this. The ecosystem can be expanded. Like I said, this is, by definition, it started with running over Broadcom ASICs. That's a definition that came from AT&T. So it was very specific. Jericho 2, that's the ASIC that needs to be in it. It evolved later on to Jericho 2C+, and of course, Jericho generations will continue to inhabit these existing devices, but there is absolutely no reason why a Marvell chip or an NVIDIA chip or a Cisco chip should not be inside such devices. So not only the ASIC itself, but hardware platforms as well. Currently, we have UV space in this ecosystem, DNI, Edge Core, additional ODMs. Celestica was mentioned here before. They are more than welcome to jump in. The specs are open, so it's just up to them to take this kind of a decision. And then not only more ODMs, but more hardware options. Not just a CPU and an NPU, but how about adding a GPU into this, or different variables of CPU, a higher capacity CPU perhaps can sustain additional functionality or different types of functionality and still embed that into the network. In fact, the idea of running inside the network kind of detaches the need to have a clear physical interface between a network and a cloud function. And there is a lot of clash on this because there is always an issue of high availability when you're connecting a network to a bunch of servers. So this kind of negates the need for that. And then application portfolio. I mentioned a whole bunch of things. It's by definition absolutely 100% sure that there are other ideas, and maybe and probably even better than what I had in mind. And of course, this is an innovation community, and I expect more things to come in this case, and probably better ideas than what I had in mind. This is just to show what a DDC looks like. All the boxes, the NCP, the NCF, the NCM are OCP accepted devices. So this is really standard, and anybody can jump in and join the fun. And that's kind of a call to action, I would say, to the industry. How do you get involved in this? So like I said, these are open specs. ODM companies can jump in. AC companies can engage and kind of make their path through this. Application companies building their application or taking their expertise, building it in a cloud-native manner so that it will be able to be distributed as containerized function and kind of scattered throughout the cluster, I should say throughout the network. The API is not 100% defined. We need more on the consumer side of the API in order to make it the best API possible. It doesn't make sense that the platform itself will define all the APIs, because this would be just like an ASIC vendor dictating what the SDK should look like. And it would only fit one, perhaps, or obviously the ASIC vendor, but not any of the NOSes that is running on top. This is why SAI was invented, right? To formalize this idea. There is a concept white paper which was recently accepted by the OCP that kind of explores most of these ideas and a little bit more in depth. Still, it's a concept paper, and I do expect to see a lot more coming afterwards, not only from myself, I wrote the paper, or from DriveNets, but also from the community. Like I said, this is not a one-man show. This is a team effort, and I hope to see more into it. The availability of such a product, a network cloud or a DDC implementation, is available. It's available today. It's available not only from DriveNet. Just to make a comment on here about this. The specs here for the DDC, everything that you see here, all the links are taking you directly to the OCP web pages. So nothing here came from the outside. Everything is here within this community and available for further exploration. That's it from what I had to say, and I'll be happy to take some questions if there are any.
We've got time for maybe one question. We're running quick on time.
Okay. One is good.
I had a quick. No one's. Did you go ahead? You had a question?
It's not clear to me. I mean, is it to place the function at a given place in the network, or to instantiate the function at a given place, or to communicate what the exact function that needs to be executed, or enabling something on the platform? Can you clarify that?
The idea is that we have.
Just take a quick pass on that, and if you all can talk afterwards, but just a quick.
I can answer in 5 seconds. We want to, we abstracted the hardware. We want any application to have access to the hardware without knowing what kind of hardware is underneath. So we want to define an API layer to kind of shield away whatever type of hardware is underneath it. So the application will be native. You had one more, Omar?
I'll take it off.
All right.
Offline with you.
All right, gentlemen, thank you very much. It's been a pleasure.
Thank you.